Every tab you open, every game you play, every line of code that your CPU executes, your RAM is one of the most important things that actually makes it happen. But how does RAM actually work? Well, stick around because we're going to be breaking down how RAM actually works. Like, subscribe if you like the video, it'd be greatly appreciated, and enjoy. RAM stands for Random Access Memory. The system's short-term, high-speed working memory. It stores the data and instructions that your CPU is actively using right now. Unlike your SSD or hard drive, RAM is volatile, meaning everything inside of it disappears when the power is removed. Now, modern computers often use DRAM, aka Dynamic Random Access Memory. Each bit of data is stored in the tiny structure called a memory cell, made from one capacitor. Stores charge equals the bit. One transistor acts as a gate to read/write the charge. This design is called 1T1C. A charged capacitor represents a 1, and an empty capacitor represents a 0. And inside of a RAM chip, billions of these cells are arranged in a 2D grid. Rows equal word lines, columns equals bit lines. When the CPU wants data, the memory controller, 1 activates a row. This then opens an entire page of memory. 2 selects the column containing the exact bit or byte. 3 reads or writes the charge. 4 pre-charges the row to prepare for the next access. Now, this ability to jump directly to any row/column is why it's called random access. Now, capacitors leak charge fast. Within milliseconds, a 1 would fade into a 0. To prevent data loss, the memory controller refreshes every cell thousands of times per second, typically every 64 milliseconds. This is why DRAM is called dynamic. It must be dynamically refreshed to keep data alive. So here's the real workflow. 1. You open an app. 2. The OS loads the program code and working data from the storage into the RAM. 3. The CPU requests specific bytes using memory addresses. 4. RAM responds in nanoseconds, feeding the CPU exactly with what it needs. Because of RAM is so fast, your system can multitask, load assets, and respond instantly. If the RAM is full, the OS starts swapping to the SSD, which is much slower, of course. This is when your PC starts to feel quite laggy. But modern DDR RAM transfers data at billions of cycles per second. For example, DDR5 can exceed 4,800 to 6,400 megatransfers, delivering a 51 gigabits per channel. Dual channel doubles available bandwidth. Higher frequency equals faster data movement. Lower latency equals quicker access to each memory cell. Now, RAM is fast, temporary. SSD is slow and permanent. Cache is even faster and sits inside of the CPU. Now, VRAM is specialized memory for the GPUs. ROM stores permanent instructions. Now, more RAM means, for example, more apps open at once, less swapping to slow storage, smoother gaming asset streaming, better performance in creative tools. But RAM isn't magic though. If your CPU or storage is slow, adding RAM won't fix everything. For example, like people think more RAM they have, the better performance they have in games, which is just not true. That's mostly based on GPU and the CPU. RAM does play a very volatile part, but mainly for memory and multitasking, not for in-game performance necessarily. So with that said, that's RAM. Billions of tiny capacitors storing bits, refreshed thousands of times per second, feeding your CPU at an incredible speed. It's one of the most important components inside of your entire system. Anyway, that's it for today. Follow for more tech tips. See ya.